This is the second part of the review at the beginning of Chapter 5. Just like I mentioned for the first one, this is a review, so I'm going to go kind of quickly through this. If there's parts that you need more clarification on, check through the textbook on the specific sections that might be of help to you. So we did exponents in the first one. This is going to be polynomials. So a polynomial is separated by plus-minus signs. Okay, no division, integer exponent, so no x to the 1/2 or x to the -3/4 powers or anything like that. You can name a polynomial in a couple of different ways. One is by the number of terms. So a monomial has one term, a binomial has two terms. So for example, x squared plus 3 is a binomial. It's got two terms. A trinomial has three terms. We can also talk about the degree of the term. So in my x squared plus 3, the degree of the first term is 2. In fact, that means that the degree of the whole polynomial is 2. So take a look at some of these, right? Maybe we'll take a look at this second one over here. Combine like terms. So x squared and -2x squared are like terms. So 1 minus 2 is -1. So I get a -x squared. Take a 2x and a -3x, and I get -1x. And then -3 plus 1 is -2. So that's a trinomial. Its degree is 2 because the degree of the highest term is 2. Look at the next one. The next one's got a minus sign in between it. So that negative sign gets distributed to everything in the second piece. Right? So you might want to rewrite this out. 3x squared plus 5x minus 4. Now watch what I'm going to do. I'm going to say minus 2x squared. Negative makes a plus, so plus 6x plus 1. Notice I wrote them underneath each other. So when I go to combine like terms, I just go 3x squared minus 2x squared is 1x squared. 5x plus 6x is 11x. 1 minus 4, -3. All right, so there it is. I've combined like terms. I've got a trinomial of degree 2. For the one down the bottom, I'm going to need a common denominator for each part. So I'm going to need a common denominator for the x squared terms and for the x terms. The x squared terms are easy, right? I've got a quarter x squared minus 3/4 x squared. But look at the x's. I've got a plus 6x minus a minus makes a plus 1/5 x. So a quarter x squared minus 3/4 x squared, a quarter minus 3/4 is -2/4. And is 6x plus 1/5 x? Well, I've got two ways I can do this. The 6 is the same thing as 30 over 5, right? 30 over 5 is equal to 6. 30 over 5 plus 1 over 5 is equal to 31 over 5. And now I can actually simplify that -2/4 to -1/2. So I'll get -1/2 x squared plus 31/5 x. The other thing I could have done is if you look back at my 6 and my 1/5, 6 plus 1/5 is 6 1/5. And if you remember that old trick, 5 times 6 is 30, plus 1 is 31. So I could have made it a mixed number, then converted it back to a fraction. All right. Oh my goodness. What if somebody was in a bad mood and they gave you problem number 2? What are the like terms here? I've got x to the thirds. I got x squared y's. I got xy squares. I got y cubes. Do I have anything different in the second ones? No, I got x squared y's. I got xy squares, and I got y cubes. Okay. So let's try grouping things together. So I've got a 7x to the third. I've got a 2x to the third. Plus a 5x squared y, and an 8xy squared. Now look at the third term. The third term has a minus before it. So everything here gets its sign changed as we go along. So it becomes a minus 5x squared y. It becomes a minus 2xy squared. And it becomes a minus y cubed. So do you notice what I did is I went to this first block over here, and I just lined up all the like terms underneath each other, because it's going to make it easier for me to find them when I go to combine them. So how many x cubes do I have? I've got 7 of them plus 2 more of them gives me 9 of them. So I've got 9x cubed. Look at this. The 5x squared y and the negative 5x squared y zero out. I'm left with just the original term, which was 4x squared y. Look at the xy squares. I've got 7 plus 8, which is 15. Subtract 2, and I've got 13. And now a negative 3 minus 1 more is negative 4. Notice this is as good as it gets. You can't combine anything else. You've got x to the thirds and you've got x squared y's, but they're not the same term. Just like an x to the third and an x squared are not the same term. So this is just a polynomial of 4 terms. After we go monomial, binomial, trinomial, we don't have quadnomials and quinnomials. We just say it's a polynomial of 4 terms. All right, if you want to multiply polynomials, everything on the outside gets multiplied by the inside. So let's pick one. Let's pick number 3. Everything on the outside gets multiplied by the inside. So 5x to the third, and if you want, you could certainly expand this whole thing like this. You could write 5x to the third times negative 2x cubed plus 5x to the third times 7x plus 5x to the third times negative 1. You can do that at the beginning, but I'm going to suggest that you get better at distributing so that you don't have to expand these things every time you do it, especially if you're going on to courses beyond intermediate algebra like pre-calc and calculus. You want to get good at doing the basic stuff. So 5 times negative 2 is negative 10. What happens with the x's? X to the third times x to the third is x to the sixth, right? We're multiplying polynomials. Over here, 5 times 7 is 35. X to the third times x is x to the fourth, right? Don't forget that's really an x to the first. And then I get a minus 5x cubed. Right? So that's where it is. I've simplified it. All right, look at the first one up there. Notice the 3xy is on the right-hand side. I want to do at least one where you've got the number you're multiplying by on the right-hand side, because so often we tend to put those things on the left. But you can distribute from the right also. Distribute a 3xy to a 3x cubed. 3 times 3 is 9. X times x cubed is x to the fourth. Carry down the y. Right. Distribute this now to that x squared. 3 remains the same. X times x squared is x to the third. Y. Minus 5 times 3 is 15. X times x is x squared times y. Done. All right, the one underneath it is just a little bit more challenging because you've got x's and y's and a negative. But just take it step by step. Negative 3 times positive 2 is negative 6. If you're multiplying by xy, what that basically means is when you multiply each of these terms, their x and y powers are going to go up by 1. So instead of x squared, y squared, you're going to have x cubed, y cubed. Negative 4 times negative 3 is positive 12. When you multiply that by xy, now you got 2 x's and 2 y's. Negative 3 times 8 is negative 24, xy, and there's my answer. Hi, how about foiling? Foiling is a shortcut when you're multiplying 2 binomials together. It only works when you're dealing with 2 binomials. It doesn't work for a binomial and a trinomial. It doesn't work for 2 trinomials. It's just a multiplying shortcut when you're dealing with 2 binomials. So first outside, inside, last. That's what FOIL stands for. So first are the first 2 terms. So x times x is x squared. Now do the outside. So the x and the 5 are the 2 outside terms. They're the furthest on the outside of the 2 binomials. Then do the inside, which is just what it says, the inside terms. And then do the last ones. 2 times 5 are the last terms. So you'll multiply x times x and get x squared. X times 5 is 5x. 2 times x is 2x. 2 times 5 is 10. And then add them together and simplify. So the only 2 things that simplify are the 5x and the 2x. 5x plus 2x is 7x. And we're done. First outside, inside, last. It's one of those things everybody remembers from algebra. All right, let's pick one. Let's pick number 2. X minus 4, x minus 5. So when I multiply the first, x times x is x squared. Multiply the outside, x times negative 5 is negative 5x. Multiply the inside, negative 4 times x is negative 4x. And then the last terms, negative 4 times negative 5, are positive 20. And you'll be able to simplify the 2 on the inside here. So negative 5x minus 4x is negative 9x. And we're done. All right, try number 4. Number 4 is going to be a little bit different because it's got both x's and y's in the same problem. So 4x times 3x is 12x squared. 4x times negative 4y, well, 4 times negative 4 is negative 16. X times y is xy. Now multiply the insides. Negative 3y times 3x, negative 3 times 3 is negative 9 times y times x. And then your last terms, negative 3 times negative 4 is positive 12, y squared. Now you realize that these are actually the same term. The order doesn't matter. So it doesn't matter whether you're doing xy or yx, it's the same thing. So you'll get a 12x squared. 16 and 9 is 25, so minus 25xy plus 12y squared. Right? So an x squared and an x are not the same term. But an xy and a yx are the same term because you're multiplying the two numbers together. Commutative property says it doesn't matter in what order. Let's take a look at 7 and 8. In fact, let's do 8 before 7. X minus 3 squared means x minus 3 times x minus 3, right? Remember, something squared is the term times itself. So x minus 3 squared is x minus 3 times x minus 3. When you FOIL that, x times x is x squared. Outside will give you a minus 3x, but so will the inside. Minus 3 gives you minus 6. 3 times 3 is 9. So that is a binomial square. Same thing is going to happen for 7. If you do 6x minus 3 times 6x minus 3, 6 times 6 is 36, so you'll get a 36x squared. Notice the outside and inside, again, are going to give us the same thing. So 6x times negative 3 is negative 18x. Combined with another negative 18x will give you negative 36x, and then plus 9. So there is a pattern. We'll remind you of it a little bit later. But is square the first term, multiply the insides by 2, square the last term. All right, notice the last one just says find the area of a rectangle with those two sides. So one side of my rectangle is 7x minus 4. The other side is 5x plus 3. Area of a rectangle is length times width. So it's 7x minus 4 times 5x plus 3. And then we can FOIL it out. In the little space we have left here, we'll get a 35x squared. Start doing the outsides and insides in your head if they're the same, because that'll give you a 21x. That'll give you a minus 20x. 21x minus 20x is just 1x. And then negative 4 times 3, negative 12. That's my area, right? Throw in a little length times width. All right, this one might look a little new to you. It says find the volume of a box with sides of x, x plus 3, and x minus 4. So if I were to try to draw a little box here, it says the sides are x, x plus 3, and x minus 4. So the volume of a box is length times width times height. So if I want the volume of that box, I'm going to multiply x times x plus 3 times x minus 4. Now, does it matter in what order I do these? No, but I can't do all three of them at once. So I'm going to do this part first. X times x is x squared. Outside, inside, so I'll get a negative 4x plus 3x, which is negative 1x. And then 3 times negative 4 is negative 12. Now distribute that x. So x times x squared is x to the third. x times negative x is negative x squared minus 12x. So we often call that standard form, right? The polynomial goes down in order of exponents, so x to the third, then x to the second, then x to the first, and then if there's constants at the end. The second part's a little bit harder. The second part says find the surface area of the box. So the surface area is the amount of cardboard that I need to build this box. So let's look at the faces. The front face of the box is x by x minus 4. The right side of the box is x plus 3 by x minus 4. And the bottom of the box is x times x plus 3. Right? So this is the front. Oh, but it's also the back. This is the right side, but it's also the left side. And this is the top, but it's also the bottom. And so once I find the product, x times x minus 4, which is what? X squared minus 4x, I'll double it, and there's two of my faces. When I multiply these things out, x times x is x squared minus x minus 12, right? I'm just stealing my answer from up here because I multiplied x plus 3 times x minus 4 at one point, and that's what I got. And then over here, multiply x plus 3 times x, and I get x squared plus 3x. And I'm multiplying each of them by 2 because there's two faces. So now I just have to come over here. I've got a 2x squared minus 8x. I'm going to add to that a 2x squared minus 2x minus 24. And I'm going to add to that a 2x squared plus 6x. All right, so my surface area is 6x squared minus 4x minus 24. All right, so I found out front and back, I found out left and right, I found out top and bottom. The last problem just says find the volume and surface area when x is equal to 6, so throw a 6 in and you'll get your answer, right? Throw a 6 into the number at the top and the 1 on the bottom. All right, last thing we're going to review are the special cases, and we kind of hinted about them before. One of them is a difference of squares, and the difference of squares pattern has the same term twice, one with a plus, one with a minus. If you learn difference of squares now, when we get into factoring, it'll make things a whole lot easier. X plus 4 times x minus 4. When you FOIL, x times x is x squared, but then when you do the outside and inside, they cancel out. Right? X times negative 4 is negative 4x, but then x times positive 4 is positive 4x, and they go away. So when you get an answer to one of these difference of squares patterns, it's not going to have a middle term. It's only going to have two terms. This one is x squared minus 16. All right, try it out for the second one here. X plus 7, x minus 7. X times x is x squared minus 7x, and plus 7x go away. 7 times negative 7, negative 49. Does it work for number 3? Sure. 3x times 3x is 9x squared. When you do the outsides and insides, you get a negative 15x and a positive 15x. They go away. 5 times negative 5, negative 25. And again, look how this is written. They're both 3x's and 5's. One's got a plus, one has a minus. The answer is two perfect squares that have a minus sign in between them. And technically, they don't even have to be perfect squares, but oftentimes at this stage they will be. All right, let's look at the last row, number 5. When you multiply a times a, you get a squared. The outsides and insides cancel again here because, look, it's a minus 6b, a plus 6b. If you were to FOIL this out, a times 6b is 6ab. Multiply these, you get minus 6ab. So again, those go away. You'll get a minus 36b squared. Okay, difference of squares. All right, the last thing we're going to look at is a binomial squared. So a binomial squared is actually what we were doing before when we were doing those x minus 3 squares. Remember I told you the pattern was first term squared, double the insides, last term squared? So here's that pattern. First term squared, double the inside, so take a times b and multiply them, times 2, plus the last term squared. The only difference between these is if there's a minus sign, there's a minus sign. Look, I put something in red and in bold, which I don't do very often, but this is my reminder that you can't just square the first term and the second term because you're going to lose the middle term. So, for example, if I gave you a 3x minus 1 squared, you would do what? You would take the first term and square it. Multiplying the insides, 3x times negative 1 is negative 3x. Double that, I get negative 6x. Take the last term and square it. Okay, so I get 3x squared minus 6x plus 1. Notice that's not the same as 3x squared plus 1, because I would lose that minus 6x in the middle. All right, let's take a look at 3. 7x minus 3 squared. So if we use our shortcut, first term squared, double the inside. So 7x times negative 3 is negative 21x. Double that, that gives me negative 42x. And then 3 squared is 9. We can do it for terms that have both x's and y's in them. All right, take a look at number 4. First term squared, 4x squared. When I multiply the insides, 2x times 5y is 10xy. Double it, and I get 20xy. And then 5y squared, square the 5, square the y. Could you sit there and FOIL this out as 2x plus 5y times 2x plus 5y? Sure. You can do first outside, inside, last, and we'll get the same answer. It'll just take us longer. Okay? If you're uncomfortable enough that you want to do that, you could certainly do that, and it'll ensure that you get the right answer. But as you become better at it, hopefully you get to that point where you can do first term squared, double the insides, last term squared. All right, and that's the end of this review. If there's some things in here that you think you need to see again, besides looking at the video again, you can always go into My Math Lab, click on Chapter Contents, and you'll see videos that were produced by the company that wrote the book, and maybe they have a more specific set of instructions that they can give you on a certain topic, or look through some of the examples that were worked out in the book as well.